Hello all, welcome to another new video. In this we will be learning what all things you will be taking away from the first unit. You need to understand what is there in the unit 1. You should have an overview, okay? And that's why this video is made. Coming to the unit 1, in this we will be having 3 chapters. This is chapter 1, chapter 2 and chapter 3. In the first chapter you will be having introduction to data structure, and in the second chapter you will be seeing preliminaries and algorithm complexity, and in the third chapter strings and pattern matching algorithms. Okay, and let's go in some detail of each of the chapters. Now if you look at this chapter 1, introduction to data structures, you'll be learning what is data structure, and you should know that data structure is a organized format of storing and managing data efficiently. You'll be seeing this particular definition from the perspective of many examples. We'll be doing that in the class. Now, where the data structures are used in databases, networking, AI, and many more. We'll see many more examples. And now coming to the types of data structures, what all types you'll be understanding or learning in this particular chapter is arrays, linked list, stacks, and queues. These are called linear data structures because their arrangement in the memory looks like linear, means one after the another. And if you look at these non-linear data structures, trees and graphs, they are mostly hierarchical. Okay, these are trees and these are graphs. These are graphs. So they are not they are, these trees and graphs are not linear because if you look at nodes, they are arranged in a very different manner, right? Now coming to the next one, that is the common operations that are performed on different data structures. Insertion. Now let me give a simple example. If you consider a array, this is an array, and if you want to add a next element, that is called insertion. Okay, and let's imagine that you want to delete a particular element. If you want to delete this element, then this is called deletion. And each and every data element will be having a value. If you want to search a particular element like 76543, if you want to search 5 in array, you'll be comparing your element with this and this. You got the element, so you will say that you have got an element. That is searching. In this way, in different data structures, these operation implementation will be different. And sorting, now if you look at this particular array, this is not in sorted order. If you observe closely, this is in decreasing order. It can be sorted, but the standard way of sorting will be from in the ascending order, that is from lowest to the highest, and this is also fine. In some way this is sorted. Now traversing, whenever you want to do some operation up on a particular element, you need to go from one end of the array to another end of the array. This is just example using one data structure, that is arrays. There are many more, and we will be learning all these operations for all the data structures available. Okay, now if you look at next concept, that is abstract data types, here you are going to define just the operations. Now I said in the list you have got different way of inserting compared to stack. Okay, we are just going to define how you are going to insert a element in list and stack, and you are not going to say how you are going to implement it. All the details of implementation are not considered in abstract data types. Okay, and in queues you are going to insert a element in different way compared to stack. Okay, and this dictionary you will not be learning here, but this you learn whenever you are studying Python and all. Okay, now coming to the next part, that is algorithm complexity and time space trade-off. This is one of the most important concept in the data structure, because let's if you take an example problem, if you want to calculate GCD of two numbers, you have got many algorithms. Let me name them as algo 1 and algo 2. Okay. These are two algorithms which can give you the GCD of the two numbers. Now this algorithm can take, and the efficiency of these algorithms are going to depend upon how many operations that they are going to perform. And in order to explain the efficiency of these algorithms, we use algorithm complexity, and there are two types of complexities. One is time complexity and another space complexity. You will learn this in detail in the class, but as of now you understand algorithm complexity is used to measure efficiency, and there are mainly three types of notations: big O notation, omega notation, and then theta notation, that you will see a bit later. Now if you look at linear search, this is having complexity of order n, and if you see binary search, it is having complexity of order log n. I'll be explaining you why it is of order n only and why it is log n only. Okay, and if you see, I said there are two types of complexities: time complexity and space complexity. In some cases you will find that if you want to execute, or if you want to find the solution to a problem using a particular algorithm, you will require extra memory. Means you will have to compromise space in order to solve a problem faster. You will see that also in the later stage. Now coming to the chapter 2, that is preliminaries. In the preliminaries you will be learning mathematical notations, functions, logarithms, exponents, and factorials. This is very necessary if you want to understand or implement particular algorithms and implement data structures. Okay, now coming to the next part, that is algorithmic notations, control statements. If you see, algorithm is represented in different way, and you'll be learning how you can represent an algorithm, because before implementing a data structure you should know what is the of algorithm of operations of that particular data structure, or how the data structure is built. For that you will be using some of the concepts like flowcharts, pseudocode, and structured programming. And then we'll use loops, how the loops are represented in algorithms, and the condition statements like if else, and recursion, a function calling itself. Okay, all these things we'll be learning in this part. And then coming to the complexity, as I have mentioned, time complexity, it will measure the execution speed. Space complexity, it will measure the memory usage. Okay, these things will be learning. And then coming to the next part, that is asymptotic notation. I said there are three types of notations: big O, theta, and omega. Now let me tell you what is the worst case and the best case scenario in simple words. If you consider an array, we have got first element as 7 and the last element as 8, and there are some elements here. If you want to search 7, you will get it in only first comparison. Okay, if you want to search 8, you will have to do so many comparisons. Okay, that's why it will take much time. If you consider this scenario, this is the best case scenario. Whichever the element you are going to search, you are getting it in the first chance itself. And if you look at the second scenario, you are going to do so many operations in order to get that particular element, so it is the worst case scenario. Okay, you will be seeing this, how these representations are given to a particular algorithm. Now coming to the next one, this is just an example of complexity comparison. If you see bubble sort, its complexity is big O of n square, and if you see merge sort, It is big O of n log n. Among these two, if you ask me which is more efficient, this particular algorithm is more efficient. Okay, we'll be telling you how we can say that this is more efficient and this is not. The next one, coming to the next chapter, that is strings. You'll be learning what is a string. Okay, if you see what is a string is just a sequence of characters you have got here, and in C programming you will see that any string is always ending with the /0, and this is one of the important concepts that we'll be using whenever you are dealing with the strings. Okay, now storing strings and operations. You see, whenever you are storing string, you will be storing it in the form of a character, sequence of characters, and you will be seeing strings data types, and what are the operations that are done on strings, like concatenation, like joining two strings, comparison, there will be two strings, you will be comparing whether both are same or not, and then searching. If you take a big text, it is actually set of strings, and if you want to search a particular string, you will go on searching. And modification, if you see text editors and all, you can actually modify if there is some error, that is text modification or string modification. Now coming to the pattern matching algorithms, there are many algorithms that you can use for pattern matching. The first one is naive approach. It means you will be, imagine you want to, in this text you want to search COM. What you do, you take this COM, compare with this. If this is not the required answer, what you do, you go for the next one, compare this, and then this. In this way you go on comparing. This is a naive approach of comparing, and the complexity is big O of n into m. You learn why it is n into m in the class. And there is another Knuth-Morris-Pratt algorithm, which is big O of n complexity. You learn this also. And Bayer-Moore algorithm, this is specially optimized for large searches. You just imagine a page containing hundreds of pages, and you want to search a particular word like COM. It will have to search lakhs of words and identify where all COM string exists. Okay, for all this will require some efficient algorithm so that your searching happens faster. Now coming to the examples where strings are used. Now let's imagine you go to the Google Chrome and you type something here like data structures. As soon as you type data structure, within seconds you will be able to see so many results here. How this is happening? This is happening by the string matching itself, and this is implemented using some of the algorithms built by Google and Bing. And then we'll be using it in word processing in MS Word and Notepad++ or your VS Code. Okay, and then DNA sequence matching, it will be used in bioinformatics. These are just the applications of strings, and that's all. This was the end of unit 1, and this is just an introduction of unit 1. This is given to you just to have a knowledge about the class, about the unit, what all things you are going to learn. And after this, as soon as we finish unit 1, we'll be having such a video for unit 2 also. Thank you.